Okay, thank you very much for coming to this session. My name is Tomoki Saito, who is a Japanese researcher working for Juntendo University. This is a collaborative research with the US people and Japanese people. In this presentation, we are going to tell you about the Resilio-centric engineering, then why we need it, and several constraints to deliver it to the students and teachers. Thanks to this conference, we got the chance to open this issue to the world. Let us talk about a changing story. From 2050, those SDGs had advocated, and many people working for education also engage in the activities and doing education for sustainable development. As many people are concerned, STEM education is also related to the SDG, and it is very much intertwined with number 12, responsible consumption and production. However, we may find that there are many links to the other all SDGs listed here. They are all about our technology and all about our design world. One of the things we'd like to offer today is a wide understanding of technology and the nature of them. According to the IDEA, the technology is modification of the natural environment through human-designed products, systems, and the process to satisfy needs and wants. The notion implies our design as an engineer always have natural impact, and it depends on the human needs and wants. Also related to the STEM education, science standards, NGSS define technology as follows. Technologies result when engineers apply the understanding of the natural world and human behavior to design ways to satisfy human needs and wants. In this notion, all types of human-made systems and processes are technology. And in this sense, most of the things around us can be taken as technology as we made. For example, society itself and organization and human behaviors are also the design world. One thing we need to know here is we are making technology, but the technology is also making effect on our behavior. Sometimes we are not aware of the effect immediately and die in the effect. Therefore, the sense STEM education fostering the activities on technology arrives late to our future society. Thus, the first claim in this presentation is that a component of technology has crucial role in STEM education. Let us see the part of technology with understanding environmental ideologies. One of our co-author, Teresa, is author of the paper discussing about the environmental ideologies. We can understand the position of each ideology as these four quadrants: Resilio-centrism, egocentrism, technocentrism, and egocentrism. To understand each position, the ontological axis and epistemological axis are important. On the ontological axis, the upper side is taken as biocentrism. In their notion, human can be taken as a part of nature, and the emergence of the system represents not just a sum of its parts, rather the interaction generates the characteristics of the system. Of course, our design world too. On the other hand, the lower two represent anthropocentrism, taken as a human-centered idea. In their notion, human can be taken as something super and fight against nature. It also can be represented by the notion of reductionism. Therefore, in their notion, the problem we face today is a result of what we have not studied. When we look at the epistemological axis, the ecocentrism and egocentrism locates on the idealist side. Their notion tend to have priority on nature of a human being and thus sometimes destroy the opposite side. For example, based on the egocentrism, we have exterminated multi-species around the world. And on the other hand, the ecocentrism sometimes denying our existence, although we cannot live from the society based on the technology. So it is a type of ideal. On the other hand, the pragmatic side, technocentrism and Resilio-centrism here. From the technocentric view, we can overcome any conflict between nature with technology. As we do today, technology in some point can cancel the environmental impact, but all the technology has side effect by nature. The effect has impact on the environment. Therefore, we shall propose Resilio-centrism here for supporting engineering in our future. Different from the others, Resilio-centrism proposes biocentric and pragmatic orientation. Therefore, in their notion, human within nature suggests managing ourselves instead of killing or managing nature or just rebelling that. Based on the idea, we are going to develop Resilio-centric engineering for STEM education. What is Resilio-centric engineering? To clarify the idea, the definition of resilience can be the clue. We can separately understand the engineering and the ecological resilience and similar term, resilience engineering. So what do they mean? We need a further discussion on the understanding of resilience. The engineering resilience focuses on stability and the resistance to the disturbance and speed to return to the equilibrium we emphasize as a property. As the ecological resilience, the magnitude of disturbance that can be absorbed supports the definition. This notion also can be supported by the idea of threshold. The magnitude means the distance from the threshold too. Also, their difference is explained by the focus on the efficiency of function or existence of function. How can we show them to the students? And Hornagel et al. Had suggested similar term resilience engineering with understanding of those definitions of engineering and ecological resilience. Their scope varies from the risk on the complex technology to management of organization. Their first notion looked based on the engineering resilience and the revised one based on the ecological resilience. Their work implies to understand the other side of resilience, engineering or ecological. The cases in past damages are supported for the studies. Therefore, as a claim 2 in this presentation, we propose to utilize engineering system to understand the socio-ecological whole. Of course, the opposite side is possible, but the ecosystem is too huge and usually difficult to use as a real example. So that was what we usually felt in the school setting. So what is Resilio-centric engineering? We need definition here. Currently, we are going to propose a definition as follows. To maintain the resilience of socio-ecological system, controlling our technology based on the understanding and the monitoring threshold of the bioenvironment. In this notion, socio-ecological system means within nature, as we saw on the environmental ideologies. When we got more insight from future effort, we may change this definition, but that is what we want to share with you today. So the audience, to join this effort with implementation, how can we apply such idea to the practice? When we consider the practical application, we usually have those common but differentiate obstacles in each setting. How can we put the assessment standard and how to move from discipline-centered approach to student-centered approach? We need specific constructs, performance expectations for the student. As a concept, resilience is difficult to observe because the ecosystem is huge and stability needs time scale for understanding, and threshold is not identified in many cases. One possibility is putting resilience on the top of the structure of the cross-cutting concepts. It is very much dependent on the idea of system, and the idea is supported by those concepts too. Also, we need to consider the phased model, which starts from learning of specific concepts of resilience and leads the student to the resilio-centric engineering. It also means that start from engineering resilience, students will get more understanding on socio-ecological resilience. I do not think that this is a hierarchical model. Rather, they have different functions in student learning: hands-on activity, field practical activity, and pragmatic orientation. Not only each part, but also as a system, this resilio-centric engineering model works. And there are several prior models to invite transdisciplinary people to work together. So we can follow those approaches within understanding resilio-centric engineering. For example, teaching resilio-centrism with social environmental synthesis with case studies, or similar term soft systems approach, transdisciplinary processes, and design-based research are advocated in the world. So when we make it possible, students identify what they learn in STEM
3 minutes
activities.
left.
Okay, that's cross-cutting concept to resilience, and the teachers can intentionally prepare for the student learning if they understand what we teach, and living from pattern to create evidence of student learning in resilio-centric STEM activity. Therefore, the claim 3, we can put resilience on the top of structure for learning with appropriate phase. Okay, those 3 claims are today's presentation, and we are going to make a project STEM note to work with and seeking colleagues. Thank you very much for listening. That's it.